Geometric transformation. Geometric transformation of shape is a change of its size, orientation, or position, following certain techniques in mathematics. The original shape is called objective, and the new shape is called its image. Many objects around us are said to be symmetrical, and this symmetry resulted from geometric transformation. Transformation means to change. Hence, a geometric would mean to make some changes in any given geometric shape. Some of the basic geometric transformation are as follows: translation, rotation, reflection, and dilation.
Geometry is one of the oldest branches of mathematics. A mathematician who works in the field is called geometer. Geometry concerned with properties and relation of lines, surfaces, solids, and higher analogues. Transformation that changes the size of a figure requires center point at a scale of factors. The action of rotating around an axis or center. It occurs when a figure is moved from one location to another location without changing its size, shape, or orientation. Flip of a figure. Figures may be reflected in a point, a line, or a plane. When reflecting a figure, the image is congruent to the image.
So let's continue anyway the topic, guys. So this is one of the examples of basic geometric transformation. So first is translation. It is said that is a transformation of an object where every point of its move is a fixed distance and a given direction. So in other words, translation changes the shape, position, or the shape can be translated left, right, or up or down. So from the word translation, guys, pwede siya maputang sa left, sa right, or down or sa up. Pero mao lang gihapon ang iyang distance ug ang iyang given direction.
These very line shapes have a very similarities to rotation. As we can see, rotation itself contains a very triangular feature of shape contained by its image. The line accords or graph by itself shapes as a triangular thing. Moreover, the very published features of shapes depends to the very value of numbers where it also been put to the different place or positions. Just like how things really made or how shapes really established according to its form. For just example, making clothes. Especially in making clothes, before it was made, there's that very periods where it connects or symbolizes as a cloth. Just how the periods of the graphs make its shape according to the value of numbers and its positions.
I am Almera Chris Omsiperalis and I'm going to explain the rotation. Rotation is a transformation of an object by rotating about a given through a given angle. And mura siya mag-rotate o peak. Any rotation is a motion of a certain space that preserve at least one point. It can describe, for example, the motion of a rigid body around a fixed point. Example of a rigid body. A rigid body is an idealization of a body that does not deform or change.
Today, I will going to discuss and explain the graph rotation. I will give some example since you already know the definition or the meaning of the rotation. The rotation has rules. There are some general rules for the rotation of object using the most common degrees of measures. So here are the rotations rule. So here are the example of counterclockwise with 90 degrees. The rules of counterclockwise are x and y will become negative y to x. So a prime will become negative 3, 1. B prime, negative 1, 2. C prime, negative 2, and 4. So to graph, negative 3 and 1. Negative 1 and positive 2. Negative 2 and positive 4. This is the A prime, the B prime, and the C prime. So connect the dots to form a triangle. So here are the result of counterclockwise with 90 degrees. So here are the example of clockwise with 90 degree. The rule of clockwise with 90 degree is x and y would become positive y and negative x. So here are the example of counterclockwise with 90 degrees. The rules of counterclockwise are x and y will become negative y to x. So a prime will become negative 3, 1. B prime, negative 1, 2. C prime, negative 2, and 4. So to graph, negative 3 and 1. Negative 1 and positive 2. Negative 2 and positive 4. This is the A prime, the B prime, and the C prime. So connect the dots to form a triangle. So here are the result of counterclockwise with 90 degrees. In 180 degrees, the counterclockwise and the clockwise have the same rules in applying the rotation graph. I will just give the counterclockwise with 180 degree example. So the rule of 180 degree counterclockwise and clockwise is xy would become negative x and negative y. So the A prime is negative 1 and negative 3. The B prime is negative 2 and negative 1. The C prime is negative 4 and negative 2. So they just have the same process in the other degrees. Always follow the rules. So here are the result of counterclockwise with 180 degree. This is the example of counterclockwise with 270 degrees. Same process, just follow the rules of each degrees. And here are the result of counterclockwise with 270 degrees. Here are the example of clockwise with 270 degrees. Again, same process. Just follow the rules of each degrees. There are the result of clockwise with 270 degrees. In the module, this is the example given. To find the A prime, B prime, and C prime, they use the counterclockwise with 270 degrees. The rules of counterclockwise with 270 degrees is x and y would become positive y and negative x. The A prime is positive 3 and negative 2. The B prime is negative 2 and negative 2. The C prime is negative 4 and positive 1. Find the value of A prime, B prime, and C prime in the graph to show the result. So here are the result of counterclockwise with 270 degrees.
I am tasked to discuss one of the geometric transformation, the reflection. Reflection are everywhere, and mirrors, glass in her in a lake. What have you noticed? Every point is the same distance from the central line, and the reflection has the same size as the original image. The central line is called the line of symmetry or mirror line. What is reflection, by the way? The reflection is a transformation of an object where every point of in its image are of the same distance from the line of the symmetry. In fact, mirror lines can be in any directions. Imagine turning the top image in different direction. Can a mirror line be vertical? Yes. Here my dog, Flame, shows a vertical mirror line with a bit of photo magic. A reflection is a flip over a line. We can flick it from to down and up, or up to down, and from left to right, right to left, or we can flip it to any directions. Thank you.
Good day, ma'am. My name is Michael Mercado, and this is the explanation of reflection graph. Reflection graph, another transformation that can be applied to a function, is a reflection over the x-axis or y-axis, a vertical across the x-axis, while a horizontal reflection reflects a graph horizontally across the y-axis.
And now I'm going to discuss the glide reflection. A glide reflection is a composition of transformations. In a glide reflection, a translation is first performed on the figure, then it is reflected over a lane. Therefore, the only required information is the translation rule and a lane to reflect over. A common example of glide reflections is footstep in the sand. A glide reflection in math is a combination of transformations in two-dimensional geometry. Reflection means reflecting an image over a mirror lane. Every point is the same distance from the central lane after performing reflection on an object. There are four main types of transformations, and those are rotation, resizing, reflection, and translation. A glide reflection is a combination of a reflections consists of translating a figure by sliding it along a lane, then reflecting the figure over an axis of reflection.
So let's go over to the topic of dilation. Dilation is just a fancy word making an object bigger or smaller. So looking at our first example, we are going to dilate ABC with scale factor of 3. So always remember, when we dilate, if we have a scale factor greater than 1, our image is going to be enlarged. It is going to get bigger. And if our scale factor is less than 1, it is going to decrease, and size it's going to get smaller. So our first example is this, ABC with scale factor of 3. So our point A is going to be 2 and 3, which is here written in the above. And our point B is going to be negative 2 and 3. And our point C is 0 and negative 3. So, muna siya ang forma sa ato ang gidilate. Muna yung triangle nga atong gidilate, which is gamay siya, diba? Small. So, pag mahuy mo na siyang prime, expected that it is going to get bigger. So, para makuha na to ang prime, since natay scale factor 3, so, kining nasa atong point A, B, C, ato ni siyang, ang numbers na nasa atong point A, B, and C, each of the numbers will be multiplied by 3. So, 2 times 3 is 6. And 2 pala 2. Hindi pala to 3. It is 2. 2, 1, and 2. Okay, 2. So, 2 times 2 again, it's 6. And then, negative 2 times 3, 6. Negative 6. And then, 3 times 3 is 9. And then, 0. Negative 3 times 3 is 9. Negative 9. So, muna siya ang atong prime numbers kini nakasulat diri sa kilid. Always remember nga pag When we say prime, para mailhan siya nga prime siya, dili jud siya kalimtan nga naay kuwit rin sa kilid sa letra. Kini, makita ninyo ni siya dito sa blue dapit na siya'y kuwit. So, para mag-graph na to siya, dili ta magbase sa prime para makita na to nga ang scale factor is going bigger. So, our A prime is 6, which is yung diri 1, 2, 3, 4, 5, and 6. So, diri and then 1, 2, 3, 4, 5, and 6. So, diri ata magbutang og point. Okay, diri ata magbutang og point. And then sa atong B prime, negative 6. So, negative ang giingon. So, diri ata mag-start sa ubos. 1, 2, 3, 4, 5, 6. And then the positive 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, diri siya sa ibabaw. So, dira ato ang point sa B prime. And then sa C prime, 0. So, since 0 man siya, linya dya punta diri and then sa ika 9. So, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, naa siya diri na side. So, layo na kayo siya, no? So, dara. So, muna mga point, muna diri atong point sa, muning dot sa atong A prime, sa B prime, and sa C prime. So, magbuhat taog new triangle. Buhat taog new triangle. So, connected na sila to diri and then 3 and 3. So as you can see, the scale factor is going bigger since nga naamantay ang atong scale factor is greater than 1. So muna siya atong A prime. Always remember nga magbutang ka og kuwit sa ibabaw, and then B prime, and then C prime. C prime. So, muna siya ako ang example number 1. So, correction lang di ay diri sa kuan sa atong C prime. Since 0 man ang nasa atong C prime, so dili day papat siya diri ta dapat mag dot diri sa may kilid. So, diri dapat din siya dugtong sa kilid. So, I'm sorry for this one wrong. Okay, that's it. So, let's go over, let's see our second example. Change na itong papel. So, itong second example is here. We are going to dilate ABC with scale factor of 1/3. So, same na Japon sa atong gibuhat ganina. Ato ang i-locate kung unsa ni siya nga numbers ang nasa atong point A. So, ang nasa atong point A is going to be negative 6 and 9. Negative 6 and 9. And then nasa atong point B, it's going to be negative 3 and 3. And nasa itong point C, it's going to be 3 and 6. Natong kuan. So, para makuha na to, Japon ang ato ang A, B, C, and ABC prime. Ang atong himuon is, kini manggod ang ato ang second example. Muni siya ang ato ang factor nga lesson 1. So, diri mahitabo nimo diri imong himuon kay i-times Japon nimo ni same sa pikas, i-times Japon nimo ang number diri sa imong scale factor nga 1/3. Okay. So, diri mahitabo nga once nga mag-times ka aning 6 sa 1/3, mura siya og nag-divide ka aning 6 sa number 3. Like 6 divided by 3. So, it is answered with negative 2. Negative 2 And 9 divided by 3 is 3. So, inana lang siya. Kung dirian na example, para dili ka maglibog, instead nga i-times ni mo isud ni mo yung kagalingon nga mag-times ka ng 1/3, makakabaloon sa ng 1/3. So diri lang ka mag-focus sa number 3 sa iyang denominator. Denominator ba tawag ana? Diri sa ubos na number 3. So 6 divided by 3 is 2. 9 divided by 3 is 3. So 3 divided by 3 is negative 1. Negative 3 divided by 3 is negative 1. And 3 divided by 3 is 1. Muna tong B prime. And 3 divided by 3 is 1. And 6 divided by 3 is 2. So, muna tong C prime. So, muna tong ABC prime. So, same sa PCAS. I-locate na to kung asa siya dapit ma-factor. Asa siya dapit na may dilate rather. So, ato siyang i-locate diri sa atong graph. So, atong A prime, which is 2, negative 2, and 3. So, since kay negative man ang nauna, diri dito sa ubos kay positive, negative, and then negative, positive. Ana ang dagan sa graph. So, negative 2. 1 and 2, and then 3. 1, 2, 3. O, diri tamag butang og dot sa prime A. And then sa prime B, since negative 1, so diri ata 1 and 1. 1 and 1. And then sa prime C, sus naaman diri ang C sa PCAS, so diri ata magbutang og 1 and then 2. So positive man siya. So libog basa ko maguna. So 1 and brother, paano ba to? 1 and so sa 1 and 2 sa C prime, let's put our dot here. 1 and 2. So 3 So atong himonda ato ang triangle. Another triangle. So our A prime, B prime, and C prime. So as you can see, as you observe, the factor is going smaller. So mo ni siya ang ato ang second example. Napakita siya nga ang atong factor ng gamay. Kay ang ato ang scale factor is less than 1. So mo ni siya. And that's it for today. That's it. I hope you understand my discussion. Thank you.